All right, everybody. Good morning. Thank you very much for joining me on this journey through UVC Light. This will be an hour of your time. We'll leave about 10, 15 minutes at the end for Q&A. And we will be going through, as I mentioned before, UVC disinfection, especially in relationships to this post-coronavirus world. So my name is Dan Litvin. I'll be joined by Mike. Mike will be on for the Q&A portion of this webinar. And I'm the co-founder and president here at Pure Lighting Company. As a firm, we are engineer, design, deal. And speaking to you, our goal here is to promote and educate about UVC disinfection. It's an incredibly powerful tool in this new paradigm of building practices. And we're here to support you with any installations, specifications, or projects that you may go forward with. And if we don't get that privilege, then at least we hope that you go and provide safe and effective implementations of UVC. So without further ado, let's start to dig in. So we have a lot to cover today. Before I start to get really into the nitty gritty, let me go through a few PSAs here. So first off, if you have any questions at any point, we will answer them at the end of the webinar. Please use the Q&A module that's built into Zoom. You'll see that on your little taskbar screen. That allows us better access to the questions and allows us to know who asked which question. Therefore, if there's a longer explanation needed, we can reach out to you after the webinar ends. Also, you will receive an email follow-up within 24 hours. In that follow-up, you'll get a recording of this webinar. That way you could catch up on any of the exciting parts that you missed. I know you're on the edge of your seats right now, thrilled about UVC technology, or maybe hopefully you will be by the end of this. In addition to that, you'll get a very short little questionnaire that provides us the information we need to get you your credits for this webinar. So if you do not, for whatever reason, receive that follow-up email from us, please reach out to us in 24 hours. My personal email is dan@pure-lighting.com, and we'll make sure that we get you all of the materials. So diving in, again, a lot to cover today. We'll be going through some background with UV. So historically, where does UV come from? This is not a new technology. It's a new application of the technology. What is UV? What's UVC? And how does UVC seemingly magically disinfect pathogens? In addition to that, we'll go into UVC Demystified. We're going to answer a bunch of frequently asked questions, such as, is UVC effective against COVID? Is UVC dangerous? Is it expensive? Is it even allowed to be used? It's funny enough that about a year ago, this time, maybe you could say about 10 months ago, UVC was seen as a fringe technology. Now it's widely accepted, widely implemented, and I'm sure all of you have been receiving many questions about it. We're going to go into applications. So overview different technologies and solutions. We're going to get into a little bit of the technology behind it, and then wider scope, facility-wide solutions, whole room, HVAC, air purification, different ways you can implement UVC in the facilities that you're working with. And then, as mentioned before, question and answer at the end, probably the most important part. So gather your questions, ask them, and we're looking forward to that part where we can interact a bit. So a little bit of background with UVC. As I hinted at before, UVC is by no means a new technology. In fact, UVC is as old as time itself. If you watch that great documentary, The Land Before Time, with your children, you were seeing UV light with the dinosaurs. UV light emanates from the sun. It's a naturally occurring aspect of the electromagnetic spectrum. But in terms of us humans, we first discovered it in 1801. In 1877, so quite a while ago, we discovered that UV light has an antibacterial property. From there, more developments were made pretty rapidly, to the point that in 1910, the first UV-based, it was actually UVC-based application for disinfection was used, and that was a water treatment facility in Marseille, France. So if you notice here in 1934, first modern fluorescent lamp was developed. We are lighting people. That's not us being nerdy about lighting. That was there very much on purpose because fluorescent technology, which a lot of you are probably very familiar with, especially if you've been doing what you've been doing for more than 10 years, fluorescent technology and most of the UVC technology we're using nowadays is essentially identical. And so this technology has been used for quite a while. Now, the year 2020, we got this little thing that you may have heard of called COVID-19. And COVID-19 has completely uprooted many industries, has caused a new awareness of disinfection-based practices. Again, that's likely why you're here. And 2020 was the instigation, was the start of a renewed interest in UVC. And one of the things that happened with UVC Light is that it modernized. It was a stagnating, let's say, industry, and it started taking modern lighting controls and making it much more robust for facility-wide applications in hospitals and schools and apartments and hotels, ballrooms, convention centers, whatever it may be, there's an application with UVC. So what's ultraviolet light? Why do I keep saying this word UVC? What's the distinction? What's the difference? So ultraviolet light is a band in the electromagnetic spectrum. It's just shorter than the visible light spectrum, the spectrum of light that we can see with our bare eyes, unless you started doing some of that biohacking and now you can start seeing infrared light, in which case you might want to see a doctor. But let's assume that's not the case. In that case, 10 nanometers to 400 nanometers is the UV light spectrum. It falls just shy of violet light. It is a shorter wavelength, therefore it's a more powerful wavelength. Therefore, it is aptly named ultraviolet light, UV light. UV light, as I mentioned before, naturally emanates from the sun. It is something that we're exposed to on a daily basis. And it's the reason why we do things like get suntans or wear sunblock at the beach. Now in UV light, there are subsections, and those different subsections will have different biological, chemical properties. And so you have UVA from around 315 to 400 nanometers. This is the most common UV light that occurs on planet Earth. It accounts for about 95% of the ultraviolet light. And this is what gives us the beautiful bronze glow that we get when we hang out at the Jersey Shore. This is something that we'll see in tanning beds, black lights, forensics, when someone's checking our banknotes, or if you're young enough or you have a baby face like I do, if you're going to a club and the bouncer's checking your ID, that is using UVA light. UVB falls from 280 to 315 nanometers. This is mostly absorbed by the ozone layer. Only 5% of the naturally occurring UV light on this planet is this. And this is the most dangerous ultraviolet light there is. This is responsible for sunburn, eye issues such as photokeratitis, or can be responsible over long-term exposure to cataracts, skin damage, and even cellular issues. This is definitely carcinogenic, so UVB is probably something that you do want to be mindful of, and it's the reason why you wear sunblock, the reason why you don't want to be under the sun for too long, and it's the reason why, again, we get skin issues that are related to the sun. Other aspects of UVB are for curing ink and adhesives. You might have it in your industrial printer, and there's also, oddly enough, some cancer treatments that use UVB. Finally, and for this discussion, the most interesting, the thing that we'll be talking about for the rest, we won't really touch any of the other ones going forward, and that is UVC light. UVC light falls from the 100 to 280 nanometer range. This is completely absorbed by the ozone layer, so it does not naturally occur on Earth. It has to be developed by either a fixture that's purposely designed, and it's also a byproduct of welding technologies. This has very unique properties that make it incredibly effective for disinfection. While UVA and UVB have some antibacterial properties, UVC has the property to treat bacteria, mold, viruses, and other pathogens. And then finally, just for academic sake, that range from 10 to 100 nanometers is something that we rarely talk about. It only exists in a vacuum. Sometimes it's called VUV, EUV, extreme UV, and it's used in high-end physics, again, beyond the scope of my little brain there and beyond the scope of today's discussion. So how does UVC treat? So UVC has a very, very special photobiological effect where it's powerful enough and the wavelength is small enough to penetrate directly into the DNA and RNA of pathogens. What happens there is that it rips apart the nucleotide bases that exist inside the DNA and RNA, and it binds together the thymine dimers. By doing that, it completely disrupts the DNA and RNA by disrupting the, that base life-giving aspect of these viruses, pathogens, whatever they may be. The pathogen can no longer replicate. If it can't replicate, it can't infect. So therefore, that's how UVC is a powerful disinfectant. And the way that it treats is unique, but not completely different than the chemical effect that a bleach or chemical cleaner will have. So again, it's a well-known, well-tested way of disinfecting. What science has shown is that the range from 250 to 270 nanometers is the most efficacious UVC. That's the range that we're going to be talking about for the most part today. We'll have a bigger discussion about wavelengths a little bit later. I know it is something that you can't wait for, but give me a little bit of time so we can build up to that. So, benefits of a properly designed UVC disinfection solution. Something that I'm sure that you guys are all looking at right now are ways that you could implement passive and active disinfection built into your facilities. How can you make safer facilities? That is one of the major paradigms happening with new buildings going forward after this pandemic. And so the reason that UVC is going to stand out is something that we'll talk about as we go forward, but it's effective, it's safe, incredibly friendly for facilities, it's future ready. Can't stress that enough. It's great against SARS-CoV-2. It's going to be great against essentially any pathogen. It's been proven very effective against every pathogen it's been tested on. Should continue that way. It's very versatile and budget conscious, has an incredibly fast payback period. So UVC demystified. We're going to break into some of the frequently asked questions about this technology. First off, the elephant in the room. This question was asked from us much more when the pandemic started. At this point, it's pretty much old hat, but we'll answer it anyway. And that question is UVC proven to disinfect SARS-CoV-2? Of course, SARS-CoV-2 is the viral strain responsible for COVID-19, the coronavirus. And the answer to that is a resounding yes. Research has proven again and again and again and again that UVC is highly effective. There's been research from many well-known journals, peer-reviewed, that show the efficacy. And with the efficacy, something that does need to be spoken about here is that underlining is that for UVC to properly treat SARS-CoV-2, or for that matter, influenza or staph or any pathogen, the proper dosage needs to be achieved. And dosage is, at base, a very simple calculation. Dosage, also known as fluence, is a calculation of UVC intensity times time. So if you have a relatively low intensity lamp shining for an extended period of time, the same dosage can be achieved as a very high intensity lamp shine for a low amount of time. This is something I'll actually be talking about when we speak about things like upper room GUV versus HVAC-based UVC. And as a general rule, viruses and bacteria are treated around the same dosages. Yeast require around twice the dosage, and molds might require 5 to 10 times the dosage of a viral strain. And for your information. This might mean something, it might not mean something, but research from the Boston University School of Medicine showed that it took about 5 millijoules per centimeter squared to result in a 99% reduction of SARS-CoV-2. So that'll give you around the same idea. With most whole room systems, that disinfection can be done in less than 5 minutes, oftentimes within 2 to 5 minutes. All right, next question. Is UVC light dangerous? When we first started having these discussions, when we first started implementing these systems, we had very legitimate fears from our clientele that if they accidentally were exposed to UVC, that they would disintegrate on the spot or ignite into flames of fire, or that some terrible calamity would happen. Thankfully, again, time has passed and we have a better idea of the dangers associated with UVC. So I don't want to go and diminish this at all. Long-term exposure, or let's say exposure to a high enough dosage, now that we know that term, of UVC light can result in some of the same issues as being under the sun for too long. It can cause skin burns. It can cause photokeratitis, which is that starry vision or that irritation of the eye. Fortunately, what has been shown is that those damages are temporary, that will heal. But all the same, we don't want to be exposed directly to UVC light, especially when we're talking about implementations in facilities where we're trying to grant a sense of confidence, of safety to the occupants, to our clients. And so in that case, no exposure, and we'll talk about safeguards that we put into our whole room systems. So if you are ever working with UVC light, there are some very, very simple safeguards to make sure that you remain even safer. We have an image of UV blocking glasses there. Blue blockers, same exact thing. UVC can't penetrate through glass. So if you're actually wearing glasses, you're going to be safe as well. Long sleeves when working with UV light is going to be a good thing. Again, whatever you do under the sun, you wear sunglasses and you try to wear a hat and sleeves or sunblock. Whatever you do under the sun is essentially going to work under UVC light. But when we talk about UVC, protection, there are a few things that we want to do. If we have a whole room system, then we want to make sure that we have occupancy sensors to turn off the fixtures if occupancy is detected. We want to go and schedule treatments when no one's going to be in the space. And we want to go and educate occupants on what is happening there. Knowledge truly is power. And with some knowledge, with some training, people really do enjoy having this extra level of protection in their facilities. So one thing that I do want to point out here is when we are talking and comparing against common disinfection techniques, right now, or actually now at this point, the CDC is getting behind UVC, but in the beginning, everything was chemicals, 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 chemicals. Use those chemicals, treat your facilities, wipe everything down, wipe it down once an hour, wipe down the doors, wipe down the tables, wipe down everything. What was seen at the onset of the pandemic was a sharp increase to poison control calls. And the main reason why was not accidental ingestion. That was what I thought first. The main reason why was vapors, was the fumes from these chemical cleaners. Chemical cleaners have a wet time and they have a need for ventilation. So spaces should not be occupied directly after chemical cleaners because there is a damage. UVC light, especially when it's at the proper wavelength, again, we'll talk about that later, hold on to your seats, is something that can be shut down and the space can be occupied right away. It is, again, extremely, extremely safe because it's natural. It's essentially using sunlight to treat your facilities. Great. Is UVC allowed to be used in facilities? Yes, we've implemented this in a lot of schools, and we know that school rules are pretty stringent. This is technology that's been implemented in hospitals, sports arenas, like I mentioned, schools and universities, ballrooms, hotels, wherever whatever it is, you can name it, it can be implemented. When implementing, a few criteria to look for. First and foremost, the EPA does regulate any insecticide product. So whenever you are implementing UVC, please make sure that any of the products you are specifying come from an EPA registered factory. If they are not, there is a chance that EPA will crack down on it and ask you to remove those products. If you are importing those products, there is a chance that they may never arrive to the destination because they'll be held up at port. UL or comparable, UL as relatively recently in the past few months released guidelines on UVC implementation. You know UL well, I'm sure. They are a standard across the board for safe implementations. ROHS is a good criteria as well. FCC if you're using any type of controls. And then this one is important here for medical facilities. So we're talking about hospice, we're talking about hospitals, we're talking about private care centers. FDA does regulate when we get into the medical world. So making sure that the products specified are FDA approved. Great. How about the expense? So we need to make sure that the systems that we're putting in are are possible in the first place. If you're giving if you're running out of budget for this, then there's going to be no reason to put it in. Fortunately, UVC is a very budget-friendly solution. We'll talk about the ROI in the next slide, but there are going to be many factors that affect the price. We have certifications, we have quality. Cannot stress enough the importance of quality. When we talk about wavelengths, we keep getting to that. Hopefully you are going to get excited about that conversation. And, when we get to that slide, we're all going to throw our hats up and celebrate. But the quality of the wavelength is important because certain wavelengths have byproducts that are not so savory that we do not want in our facilities. Controls and safety features, as mentioned before. I have seen recalls done for fixtures that were either defective or not properly installed with proper safety measures. Saw a huge one that happened in Sacramento, where it's a $6 million project that was completely recalled because of some of the dangers associated with technology there. That wasn't a UVC one, but I did see one, I think it was in South Carolina, where there weren't proper safety protocols. Fixtures were on when students were in the room, and that was rescinded. So again, that's where quality gets into play, making sure that you are specifying proper products, because it is a little bit of a wild west out there in terms of UVC. So you do want to have some time to make sure that you're giving the products that are going to be proper, because your name is on the line as well. We want to make sure you look like heroes here rather than anything else. And then, of course, warranty and support, stuff that you know about. Marketing and demand. When we first started, the demand was high, the supply was low. We're at a point where there are many options, and we're happy to work with many, many fantastic companies that are putting out some really amazing products. All right, so ROI. So if we're talking about disinfection, now let me make a quick little classification between cleaning and disinfection. So cleaning is when you take a desk and you take the papers off, you take the pens and you tidy it up. That's cleaning. Disinfection is when you're taking the bleach or the Clorox and you're wiping down the table and destroying the germs on there. So cleaning is something that's going to have to be done regardless. Disinfection, now when we're talking about in the time of outbreaks, whether that's COVID-19, whether that's the flu, colds, or whatever the next epidemic might be, in these times of outbreak, we need to have regular disinfection. If we're talking about in a working space, at least once a day. So taking the price of 20 cents per square foot, which is an average cost for disinfection nowadays. This cost has been calculated from looking at over 10 different commercial contractors and taking an average cost. And I actually removed a bunch of the outliers that were priced way higher than that. And applying that over a 500 square foot area, that would cost $100 per disinfection. If you're taking that for every working day, around 260 per year, that's going to be $26,000 of disinfection for only a 500 square foot space. Extrapolate that into the spaces that you're used to working with, and that number gets astronomical. So for the same area, that would require only one 2x4 recessed fixture. If we're talking about whole room disinfection, surface and air, plus the labor, a high cost, this is counting off of MSRP, would be around $1,100. That means that the UVC payback period is 11 days. So when clients are looking at this, this is going to save them money over, I don't even want to say the long term, over the short term. The extra utility costs are tiny. There's no, bulb replacements for at least 5-6 years. And when that happens, each bulb is maybe $40, $50. So again, it's savings right away. And we're not even talking about the cost of missed days for people being sick without a very proper, robust disinfection protocol in place. Okay. So finally, the good stuff, applications. How do we actually put in UVC into our facilities? Well, first off, we need to ask the proper questions. So we need to understand what are our clients looking for, or what are we trying to do in our design? So a few questions that are going to be helpful to ask include, what's the purpose of the system? Are we trying to disinfect surfaces or air? Two very different systems based on that. Are we trying to achieve primary disinfection or supplementary? Do we have other disinfection means and we're trying to add an extra level of protection? Or is this our main means of treating spaces and making them safer? And then finally, what is preferred, and let's say, what can the facility allow? Do you want a more effective direct treatment that can only be performed when spaces are vacant? Or do you want an indirect treatment that's going to treat the air, but something that can be activated while spaces are occupied? Again, questions to ask. We'll go through different solutions based on these. And then in terms of designing the systems, many engineering-based considerations. This is something, a lot of you guys have a good idea with lighting, and even with standard lighting, there are a lot of considerations. We're not just talking about things like, form factor and aesthetics, even though that is something that's important here. We're also talking about what is the reflectance of our walls, of our floors, of our ceiling. What kind of foot candle output do we want, when we're talking about LED lighting? So we have the same ideas here. Room dimensions, shape of the room. What's the furniture layout? If there's a lot of furniture, there's going to be a lot of shadows. We'll need more fixtures in order to cover those shadows. What's the airflow like? To a degree, what's the reflectance of the ceiling, the walls, the floor? What's the schedule of operation? So a lot of things that need to be considered there when designing a proper system. Again, that's why it's nice to have a network of experts. I'll just shake my shoulder off right there a little bit. Okay, so let's get into some of the technology that UVC Light comes from. So first off, we have different bulb types, and these are the three main ones you'll hear about. First and foremost is the low pressure mercury. This is, again, essentially fluorescent technology. The only difference between this and fluorescent technology is A, the gas inside, B, the pressure inside is a little bit different, and C, there is no coating that inhibits the ultraviolet light from coming out like a fluorescent has. Everything else is essentially the same in terms of wattage, lifespan, etc. Next up is excimer. This is a technology that's similar to metal halide lights. The one thing that is different, that is nice with excimer, is that it does allow for instant on. It's not that 5-minute warm-up time that we had in the old gyms or old warehouses. Excimer technology is used primarily when we talk about 222 nanometer UVC. We'll mention that in the next slide when, again, we talk about wavelengths. And that is a wavelength that is a very interesting one. It is more expensive and does require more power than low pressure mercury, so it's not something to use across the board. And finally is LED. We know in our lighting, the LED revolution that changed everything, that made things a lot more interesting, that allowed us to have all this unique control over lighting. Unfortunately, that's not here with UVC quite yet. At this point, LED is not powerful enough. It's prohibitively expensive. And some of the technology, such as providing proper heat sinks, is just not there yet. So we are hoping that LED undergoes a transformation, or UVC LED undergoes a transformation, and maybe in 3 to 5 years, we could be having a whole different discussion and pretty much not talking about the other two, because LED will allow completely fine-tuned control of the wavelength, which is again, a very exciting proposition there. And then a few notes. Again, we're talking about low pressure mercury, pretty much fluorescent technology, so ballast will be needed. Lifespan tends to last at least 8,000 hours. This does, of course, depend on the type of usage. There are some systems that will be turned on and off and kind of cycled through on a quick basis. That's going to burn out the ballast quickly and you'll get less life. If you're talking about a system that's turning on maybe once a day to do a treatment from 2 to 2:30 a.m., you're going to get more life. And then with the low pressure mercury, the effectiveness of the lamp slowly degrades over time. That's why we recommend providing an overpowered system and then letting the lifespan last a little bit longer that way. And finally, we get into wavelengths. So wavelengths are interesting to me. We'll see how interesting they are to you. I was trying to find some golden goose that we could keep ourselves connected and rallied around through this webinar. And hopefully this is it. There's a lot more interesting stuff that happens after this, so please don't sign off right away. So the wavelength that we talk about most is 254 nanometers. To be precise, it's 253.7 nanometers. Now, this is a range that the low pressure mercury lamps can very easily achieve. This is just shy of the peak germicidal effect for UVC. So it allows a very, very effective treatment. This is the technology, again, you're going to see most often with UVC-based technology. Now, 260 to 280, this is the true peak of UVC effectiveness. Unfortunately, with low pressure mercury, you can't achieve that. You can achieve it with LED, but you're not going to be able to achieve that light intensity that's going to negate the effects. So in the future, when LED technology catches up, you'll be able to get even more effective. The dosages will be quicker to achieve than at this point, but again, not quite there yet. Next up, this is important. This is something that you might have seen, that you might be aware of, that I really, really want to stress. That under the wavelength of around 240 nanometers, ozone is a byproduct of UVC. There are many fixtures out there that you're going to see at the 185 nanometer range. They might be exclusively there. They might be 254/185. This is a low quality product. It's easy for low pressure mercury to hit a wide range. It's more difficult and it takes a higher quality product to maintain that 254 range. And so if you look on Amazon, which is a slightly terrifying place in the world of UVC, you're going to see dual use disinfection, UVC and ozone. Yes, ozone does have ability to disinfect and to treat. Wonderful. But ozone is also going to cause a slew of problems. It's going to be very, very toxic to occupants. So you don't want that in the air. If there is an ozone leak or ozone generated, you're going to need at least 30 minutes in a well-ventilated room, more likely longer with windows open to clear that out. I was just talking to a lighting expert yesterday, and he was saying that he was doing some testing with some of this low quality UVC in his garage. He had a one-car garage, tight garage, and he had a bicycle in there. And the bicycle tires degraded completely from doing this testing. And what he found was that it was primarily the ozone that was generated that degraded the tires there. So we do not want that range. Okay, off the soapbox there. Now you know 222 nanometers. This is where we get interesting. So 222 nanometers has a lot of promise. This has been a wavelength that's been widely studied at Columbia University. And at 222 nanometers, the idea there and the research so far has shown that it doesn't penetrate into the skin and it doesn't penetrate into the cornea of the eyes. That means that it could be disinfecting a whole room with zero damage to the skin, to the eyes, or to people. Now, there's a few things that we need to note here. One, the research is still young. This was first discovered about 3 years ago, and it does need more peer-reviewed research to really show that this is going to be something that truly meets that. It has been shown at lower dosages that have been fine, so we often recommend 222 nanometer systems in places that are quickly passed through. So maybe things like kitchens where someone's there for 30 minutes, maybe in an elevator, maybe in a hallway, something along those lines. Number two, 222 nanometers, it does produce a slight amount of ozone. Very, very small. So it's not like the 185 that is an ozone generating machine, but all the same, you will need good ventilation in a 222 nanometer system. And three, it is more expensive to implement. So it's not going to be a system that you can have facility-wide. It's going to be more of certain unique spaces. And then finally, last one here to talk about is 400 to 405 nanometers. This is not actually in the range of UV light, but this is something that many of the lighting reps do contain products of, and they are trying to sell. And it's good enough products in the sense that it's antibacterial. It's not antiviral. It's not going to do anything for SARS-CoV-2. It's not sporicidal, so it's not going to help with mold spores, but it's going to treat some bacteria. The other thing that's good with it is that there's no danger to skin or anything like that, so it can be on in facilities. And finally, if you need a vandal-resistant option, it's a good thing to put in. So if you're talking about prisons or, I don't know, a batting cage or something like that, that you need to go and have something very sturdy, this with some sort of air purification system might be the best bet. All right, so let's get into some different systems here. So first and foremost here, we have whole room direct disinfection. This is something that I've been alluding to for pretty much this entire webinar. And the idea here is that you're getting the most effective treatment. You're using fixtures, very simple lighting-based fixtures with controls we'll talk about in a moment, to go and treat the air and surfaces. This is something that can only be done during unoccupied spaces unless you're using a 222 nanometer system. Again, 222 nanometer systems are going to be great for places that people are not spending a lot of time in. Lobbies, elevators, hallways, kitchens, places like that. 254 nanometer is going to be nice for your more standard places that you do have times of non-occupancy. Offices, meeting rooms, classrooms, whatever that might be. And so the idea here is you do want high-end controls. You do want controls that are going to provide you safety and flexibility. On the safety side, you want to make sure that there are occupancy sensors built in to shut down the fixtures if occupancy is detected. In terms of the side of flexibility, you want to be able to pre-program these. What we've seen again and again and again is facilities that want these lights on like from 3 to 3:30 a.m. when no one is in the facility. It does a disinfection, again, while the space is empty, treats the surfaces, treats the air well, and is effective on that side. And this is, again, highly effective technology here against current and future outbreaks. Something you'll see there is portable fixtures can essentially do the same thing. Only thing there is that you have the whole manual entry. If you're designing a new facility, there shouldn't be too much of a need for portable fixtures. The in ceiling, or as we talk about in a moment, HVAC-based systems are going to be effective. And then I want to mention the handheld, just because it's too good to pass up. The handhelds are kind of they're a wild thing. You have some of them which are amazing, and they're so good for spot cleaning because they're able to get a very tight beam, very high intensity, and that's great for things like your keyboards. That's great for things like the cafeteria trays, sports equipment, musical instruments, whatever you want to do that way. There's also a lot of them which are complete garbage and junk. If you look at the bottom right, there's this little wand there. My colleague Mike, who is doing the Q&A, was actually just at a client the other day, and he purchased 60 of these wands for his school district. He's told by his higher up to purchase them, and Mike had a UVC meter. So it's like, okay, let's measure this up. With the measurements that they got from this wand, it would take about 4 hours to treat a 8.5 by 11 inch sheet of paper. So a lot of the stuff you're going to see out there is no good. Again, if you're buying for home use, do a little bit of research. And it's also good to have a UVC meter to make sure you're achieving proper dosages. Okay, back to our scheduled production. Next up, this is one that you are probably hearing a lot about. This is one that is high and mighty in the specification market. And there's a lot of goodness to this, and it's upper air UV systems. So the idea with upper air UV systems is that you're taking UV fixtures, putting them on the wall or the ceiling, aiming them up at the towards the ceiling. Now what you're doing here is you're taking a high-powered beam, irradiating towards the ceiling, and disinfecting that air there. Now there's always natural airflow in a space, so you're treating the air slowly throughout the facility. It's something that for the most part is safe. It's a great solution when it can be done properly. Now there's a few notes that we need to go and be mindful of. First off, if the ceiling in a space is too low, it's not going to be very effective. The fixtures need to be mounted at least 7 feet high. Personally, I'm not a huge fan of that because though I'm only 5'7" on a good day, there are people that are about a foot taller than I am. And if they raise their hands up, they're exposed directly to the light in that way. So for me personally, I try not to mount them any lower than 8 feet. And so the other thing too is that if you have low ceilings, you're not getting a very large amount of volume that's treated. So this is a system that's really quite great when you do have a little bit of a larger space. So I think about our foyers, our ballrooms, our convention halls. When you are trying to find a solution inside those beautiful atriums, that's not going to be too invasive. This is going to be a fantastic solution. The other thing to be mindful of with upper air systems, you want a good circulation of air. So in a room that's pretty stagnant, there's going to be a limit of its efficacy. In a room that has good ventilation, whether it's through its HVAC system or through doors opening and people passing through, it's going to be a great system. And then, of course, last thing to mention, does not treat any surface level pathogens. Okay. Next up, HVAC solutions. Now, if you are responsible for new constructions and plans, my request to you is please implement this into the HVAC if possible. It's not a very expensive implementation. It has beautiful, beautiful results. And when you are talking about new construction, it's so much easier to implement than to do retrofits and upgrades in an existing facility. And the idea there is two different types. You have option one. Oftentimes we talk about options 1 and 2. And option 1 is putting in UVC right into the air handler unit. This is going to disinfect the coils. The coils and that air handler unit is a breeding ground for pathogens. It oftentimes biofilms start to coat some of these, the coils and coat inside of these air handler units. they start to interfere with the flow of air, and they also start to pass through these pathogens into the supply ducts and into classrooms, hotel rooms, guest rooms, whatever room you might have. So option one, putting in UVC into the air handlers, so you can get a few pass-throughs, and it's going to treat, and it's going to make the system more effective and longer lasting. Option two, again, one and two is the best, and that's putting it into the ductwork. Here, you're putting in very high intensity UVC into the return part of the ducts. You do want around 10 feet of straight ducts to allow this, because remember, we talked about dosage, intensity times time. So we need to achieve a very high intensity of UVC light and maximize the amount of time, because inside our ducts, air is flowing really quite fast. So if we want to achieve that adequate disinfection, we need a little bit of a longer stretch and really highly powerful UVC light. Again, benefits, this is a pretty affordable system. It's something that's going to just increase air quality throughout a facility. And it's something where, you know, filtration inside of our air handler units, we can only do so much, because then the whole pressure system gets skewed. So this is a really great way to treat our entire facilities, you know, for whatever pathogen it might be. All right, almost last is going to be air purifiers. Now, we don't always have the option for HVAC systems, and oftentimes we want some sort of protection while spaces are occupied. Our direct UVC will not be effective during occupied spaces. Our HVAC system, it may not be providing the proper amount of air exchanges, or B, we might not be able to implement into there. So another great option is to provide UVC-based air purification. And this might be a recessed or surface mount fixture. It might be a portable unit. Portable units, we run into the risk of very odd airflow, and a lot of times the contaminated air gets locked against desks or chairs or something like that. So something up towards the ceiling does tend to be a better option. And what we'll see a lot on the market is multi-layered treatment. So you'll have dual filtration, MERV 13 or HEPA filter, drawing in some of the contaminants in the air. The aerosolized molecules of SARS-CoV-2, you know, it rides on little bubbles. Those do tend to get trapped into the filters. Whatever passes through is treated through really high intensity UVC light. And then again, one more level of filtration on the way out, 3 levels, added protection. You want to make sure that the design is proper inside of your facility to get those ASHRAE recommended air changes, so you do maximize the safety of spaces. Again, a great solution. It does not provide surface level decontamination though, so that's the one place where the solution is a little limited. Finally, last but definitely not least, is a hybrid solution. Now, the hybrid solution is the best of both worlds. This is, excuse the nerdy reference, this is one fixture to rule them all. And the idea here is one fixture that provides direct and indirect treatment, whole room and air purification. And this is going to be you know, something that really provides an excellent holistic approach to disinfection. The way that this works is you have, again, 2 uses. While spaces are occupied, usually what we'll see with a system like this is it's just connected directly to the light switch, is air purification, like I just mentioned. Now, when spaces are unoccupied, whether it's through detecting a lack of occupancy, whether it's through the controls built into the fixture, whether it's through connecting to a greater IoT-based system, a lot of different options, is whole room disinfection, as we mentioned before, surface level and air treatment, rapid treatment, highly effective treatment. If possible, if you're trying to get, let's say, the most disinfection, whole room systems do tend to be best. With this, there is the need for replacement of the filters. That was also the slide before. And you do have to have proper design to account for proper air exchanges, proper airflow, and proper dosages of the surfaces. So as we have 10 minutes left, I promised time for Q&A. So we're going to turn this over to questions and answers. So any questions that you may have here, please answer. I'm going to take please ask. I'm going to take a sip of water and then we'll get started. I already see a few questions that were posed. Great. All right. So I appreciate this question. I know that for the most part, this webinar is meant to be educational. So I'll answer this all the same. So in terms of as a company, we do have our own product line. If you went to our website, you might have seen that. But we are a engineered design. So we are a design company. We do work with multiple leading companies here in the UVC industry. And so we will be able to provide specifications based on need, whether it's from high end, more affordable, whole room, air purification, whatever it is on that side. Great. Next question. Yes, this is very important. I will send again, I said this at the beginning, I know some of you guys joined late, so I'll reiterate the PSAs. Within 24 hours, you will receive an email. In that email, you're going to get a recording of this webinar. You're welcome to share that with friends, family. If you're looking for a date night on Friday night, that might not be a bad idea. So you'll get that, and then you'll also get a very, very short informal questionnaire where we'll ask you for your name and your AIA membership information so that we can go and give you your credits. We will input into the AIA website on our end within 48 hours, the attendance here. So you'll get your credits as soon as possible. Okay, I think Mike is going to jump in here. Oh, never mind. All right. Great. So here's a fantastic question here. And it gets to the core of everything. And that's, I'm going to rephrase it because it's a little bit long here. The question is, how are dosages calculated? Or how do I know that my system is working properly? And so the idea there is it's multifaceted. First, you need a proper design. We mentioned before a dosage needs to be proper to treat different pathogens. So it needs to be a proper design. And in that design, you need to be able to make room for adjustment of the system because different pathogens have different dosages. SARS-CoV-2 has a different dosage than influenza. That has a different dosage as E. coli. That has a different dosage of staph. And so with the system, you need to be able to have enough flexibility in it that you can extend or diminish treatments properly. Now, to make sure that the system is working properly, on-site, one of the things that we recommend and one of the services that we offer is on-site commissioning and calibration. And so what we'll do is we'll go on-site, we'll go and take our UVC meter, we'll do on-site testing to make sure proper dosages are achieved. And if they're not being achieved in the time that the client needs, or let's say if they're not being achieved, we'll go and work with time. And also before, there needs to be discussion with the client in terms of what time they need for those dosages. We have been working with many hospitals and putting in UVC fixtures inside of their patient rooms that have incredibly fast turnover. And so we'll be putting in more fixtures in those than we'll put into a classroom, which we're running these only late at night. And we have, if we need 45 minutes, 60 minutes, 2 hours if we needed to run it. So those questions will need to be considered when implementing a proper design. Great. Let's have a couple more questions here. And then when I answer these questions, we'll end the webinar. So this is also another opportunity for you guys to ask your last few questions here. Amazing. I just got the same question 2 times. Okay, so then there's a fantastic question here, which is when we're talking about whole room disinfection, if we have a, perfect, that's great. If we have a drawer or we have a desk and we have that shadowed space under the desk, what about that? A couple answers here. Let's say 3 answers here. So answer 1 is going to be airflow. So there's a natural airflow in rooms, and if we also have a properly commissioned HVAC system, we're getting proper airflow, then a whole room system is going to be getting that space underneath the desk. Number 2 is that you want to make sure that, I mentioned before, one of the factors that we're considering is furniture layout. And so if you have a space with a lot of obstacles, a lot of pieces of furniture, a lot of potential places for shadow, as we might know from, if any of you practice photography, you have multi-point lighting. And the idea of multi-point lighting is to cover shadows created by another fixture. So what you'd want to do is have enough different fixtures placed in different places to cover those shadowed areas. And then option 3 is that there is, I'll be completely honest here, there is no, let's say, disinfection protocol that's going to be 100% effective for everything. So there might be some places that once in a while require a little bit of manual aid. So if you're talking about inside of a closet, right, you might need some help there. Inside of a drawer, you might need some help there. Fortunately, those areas that the light doesn't really touch are places that aren't really occupied that often. And so you don't need to do a very extensive treatment for those that often. Great. All right. This next question, I kind of answered. So we'll be taking into consideration, there's a lot. I mean, if we're talking about an HVAC system, I'm sorry, the question is considerations when implementing UVC. If we're talking about an HVAC system, we're talking about duct size, right? We're talking about, can we get into the ducts, or are we only getting to the coils? If we can't get into the ducts, do we want to bring in that air purification in that case? We're talking about the type of occupancy in the room. There's some spaces that are occupied more or less 24/7. And so in that case, a long-term whole room disinfection, that might not be the option that we have. There's going to be, as mentioned before, a lot of different spaces with a lot of different furniture, and we might need more fixtures. So it's something that's a little bit hard to answer very broadly. We need on a per application basis, and then we'll go in and honestly, we have nothing to hide. So if you have any questions that way, if you're looking at a space and you want a second opinion, send it over and we'll explain our reasoning behind it. Great. Next question. What is the appropriate distance from the UVC light to the surface? That's a fantastic question. And we don't always have control over that, right? So we have to go and find the proper way. That's the calculation of dosage, because the light intensity is going to diminish from distance. There's an exponential diminishment, just like we have with normal light. So in that case, if we're trying to do a whole room treatment and you have a lot of space, you're going to need a higher output light source and more of those light sources so you could achieve the proper dosage at the surface. If you have a very localized, where you have, a fixture only a couple feet away from the treatment plane, you won't need anything very high powered at all. So that again is going to be an it depends type of question. Now, that's if we're talking about standard whole room disinfection. If we're talking about something like upper air, as I mentioned, you don't want to put these systems any lower than, again, my colleague will say 7 feet. I like to play it safe. I'll say 8 feet. And you'd want at least several feet above that to have a proper treatment area and enough volume for the air to pass through. All right. So those are the questions that I have. I'm going to very slowly sign off of this, end this webinar. So if there's any last questions as I'm saying my final remarks, please ask them and then we'll answer them at the end. But I just wanted to take a moment and honestly say, There we go. I want to say thank you. We've been involved in lighting for a very long time. I think I've been involved in lighting for my entire life. But with UVC, it's something that we've been interested in for about 3 to 5 years now. And the past year has been so interesting. And we've, something that I've learned since a child is, whenever there's a big calamity or there's a conflict or a catastrophe, find the opportunity there. How can we grow from this? And one of the things that we've seen from this pandemic is a whole new way of looking at our facilities and our shared spaces. It's a way of looking at it that we probably should have looked at it a long time ago. And that's how do we make safer spaces? So, just by being on this webinar, it shows me the fact that there's other people, looking at this, thinking about this. We get to talk to multiple people on a daily basis and clients, and, seeing this transformation firsthand is something that's really exciting to us. So whether we get to work together in the future or this is, just an hour where you learn about UVC, I really thank you for your time. If there's ever any sort of question, please don't hesitate to reach out. We're really happy to, to talk about this and talk shop.